So in the first section of this chapter, we focused on how to select samples, and we talked a bit about designing surveys. In this section, we're going to focus on designing experiments and what it means to conduct an experiment that has good experimental design. So we are going to start off with some vocabulary, of course. The first thing we want to mention is what we call experimental units. Those are just the individual things that we're studying or that we are experimenting on. Anytime our experimental units are humans, we don't call them units because I guess that would be a little politically incorrect. We instead refer to them as subjects. So experimental units and subjects are basically the same thing. It's just we use subjects when we're talking about our fellow Homo sapiens. The other piece of vocabulary that we need for the moment is a treatment. So what a treatment is, it's what we are doing to our experimental units or subjects. It is the point of the experiment is to apply various treatments to our units, and then we're going to measure the difference in responses to each of these treatments. So of course the whole point of conducting an experiment is to see how different explanatory variables produce different response variables. Another way to say that is how different treatments produce different responses. So when we talk about explanatory variables, we often call them factors. And for each factor, we can often have, and we should have, some various different levels, and it's those different levels that we're going to be comparing the results of in our experiment. So let's do an example. Maybe back in grade school you had to do a little botany experiment where you were growing seedlings. And one of the factors that of course impact how well or how fast seeds grow is the amount of sunlight they're exposed to. So we can consider the amount of sunlight our factor, and then we could conduct an experiment by varying that amount of sunlight that the seedlings get. So maybe our various levels are no sun, could be one level. We could see how the seedlings do if they're exposed to no sunlight. Maybe another level would be partial sun, and then a third level could be full sun. So those are the three levels of our one factor, the amount of sunlight that seeds are exposed to. So we've also talked about not just experiments but also observational studies. Now, why would we rather conduct an experiment instead of an observational study? Well, an experiment, of course, gives us a little bit more control, because an experiment means that the experimenter is able to influence the experimental units in some way. We said before that when we were just doing an observational study, all we were doing was observing what was happening, so we weren't affecting any sort of influence on the outcomes. That also means that with an observational study, lots of different variables could possibly be having an effect all at the same time. So when you're doing an observational study, it's very difficult and really not accurate at all to create any sort of cause and effect relationship from that study, or to say that the results imply that there's a cause and effect relationship. All you're doing when you have an observational study is reporting what you see. You can't say what's causing what. However, that's not the case with an experiment, because if you conduct your experiment well, and you've thoughtfully laid it out, and you have adhered to all of the basic principles of good experimental design, then based on your results you may be able to say that there is some sort of cause and effect relationship between your variables. So this relates, or an example of this would be that, almost weekly, if not daily, we are inundated with various results of medical experiments. Experiments saying that one type of food is good, another type of food is bad, exposure to this is good, exposure to this is bad, because they're surmising, based on the experiments that they have conducted, that perhaps, very obvious example would be that we now know that smoking causes cancer, and that was based on not just observational study, but on definite experiments. We were able to, medical professionals were able to see the relationship between, or prove the relationship between smoking cigarettes and instances of lung cancer. So that's why, when possible, we would rather conduct an experiment rather than an observational study, because with an experiment, again, as long as it is properly conducted, you can make cause and effect statements. So of course that means we need to talk about what it means to have a good experimental design. There are 3 basic principles to good experimental design, and the first one is control. Control just means that you are going to compare your various treatments, your various factors, in the exact same environment. So you're not going to allow any other variables to come into play. So maybe, let's say we are going back to the seedling experiment. What that might mean is that in order to have control, and we said that we were going to have our 3 different sunlight levels, no sunlight, partial sunlight, and full sunlight, then we couldn't also vary something else. Otherwise, we would not be able to say or make any predictions about the amount of sunlight that a seedling needs. If we also varied the amount of water that the seeds got from group to group or from pot to pot, then we would not, we'd have no way of knowing whether it was the watering or the sunlight that was impacting the growth of the seeds. So again, control just means basically that you are in control of your experiment, and you're only allowing the variables that you want to vary to be different from experimental unit to experimental unit. Now, you do need to keep in mind the difference between this idea of control and this idea of a control group. A control group is an important component in an experiment, and that's simply the group that you're not imposing any sort of experimental treatment on. Maybe you're trying to study the effects of, I don't know, drinking a liter of Coke a day. And so maybe one group, you say, go drink that liter of Coke a day, and the other group is your control group, and they don't drink that liter of Coke a day. So the control group would allow you to sort of set a baseline for maybe what their health statistics are, their body weight, blood pressure, that sort of thing. Whereas then your experimental group is the one who's drinking the liter of Coca-Cola every day, and hypothetically we would expect to see that maybe they weigh more, their blood pressure's higher, that sort of thing. So control and control group are 2 different things. In the next video, we'll talk about the 2 other components of good experimental design.